Welcome students. This is the first part of the topic semiconductor. In this video you will study about what are the semiconductors, its type and which semiconductor is basically used in the most of the IC technology. And then the intrinsic semiconductor and its thermal properties. After this I will tell you the important concepts and frequently asked questions from the topic. So students, please watch the video completely and thoroughly. And do not forget to subscribe the channel for more contents. So let's start with the topic semiconductor. It has two words, semiconductor, which means its conductivity lies between the metal and insulator. As you know that metal has the highest conductivity and insulator has the lowest conductivity, while the semiconductor lies in between. There are two basic types of the semiconductors. The first one is single element semiconductor and second one is the compound semiconductor. In single element semiconductor, these are the materials of basically the fourth group of the periodic table, while in the compound semiconductor there will be two or more elements of the periodic table. For example, third and fifth group and second and sixth group of the periodic table. So in single element semiconductor you can see silicon and germanium type of semiconductors, while in compound semiconductor the very well known semiconductor is gallium arsenide. Among these semiconductors, silicon is the mostly used semiconductor in the IC technology. Why so? Because the first reason is it is abundant in nature and that's why it is very easily available and the devices which are using the silicon are not costly. And second reason is its energy gap. Its energy gap, which is 1.12 electron volt, is very favorable for the IC technology. It is not too high, not too low. Now let's see the 2D structure of the silicon crystal. So this is the 2D structure. Silicon has the total 14 electrons, where 4 electrons are in the valence shell. And these 4 electrons are equally shared with the neighboring 4 atoms. And in this way, this forms a tetrahedron structure. So this is the silicon atom and these are the covalent bonds and these are the valence electrons. Now the silicon crystal, you can see there is no foreign element and that's why this crystal is called as intrinsic semiconductor, which means the pure crystal is the intrinsic semiconductor. After this we will study the thermal behavior of the intrinsic semiconductor. There are two cases to study the thermal behavior. The first one is absolute zero. Absolute zero is the 0 Kelvin temperature and room temperature is the 300 Kelvin. So let's take the first case. At absolute zero, the thermal energy is very low and that's why the electrons in the valence shell are not able to break the covalent bond. All the covalent bonds are intact. It means there will be no free electrons, and if there are no free electrons then there is no chance of conduction of the electric current. That's why you can say that intrinsic semiconductor behaves as insulator at the absolute zero, and this is very important point. Now let's see the behavior of the intrinsic semiconductor at room temperature. So room temperature is 300 Kelvin temperature. At this temperature the thermal energy is very greater than the energy gap, and that's why the valence electron can break the covalent bond and therefore there will be the free electrons, and this process is called the thermal generation process. Because of thermal energy the free electrons has been generated. They leave their parent atom, and if there are free electrons then there are chances to conduct the electric current in influence of the electric field. Now the semiconductor will not behave as insulator. Now it is conducting the current. Okay, what will happen when the electron leave its parent atom? There will be a vacancy, and this vacancy is called hole. Hole is also the carrier of the current, and this hole has the equal charge in magnitude of the electron but in opposite polarity, that is the positive. Now let's see the silicon 2D crystal structure. So at room temperature, you can see the covalent bonds are broken down and the electron from this atom will move freely to somewhere in the crystal, and it is leaving behind a vacancy which is called hole. So in this way, the thermal energy has created free electron and hole in the crystal. At thermal equilibrium, the concentration of these free electrons and holes are equal, and it is called as intrinsic carrier concentration. So students, what do you think if there are free electrons and holes both having the equal magnitude but in opposite, their charge has the opposite polarity? There might be some chances that they can recombine. So this process is called recombination process. So because of the random movement of the free carriers, there will be a recombination process which is ultimately depending upon the temperature. So in this way, we can say that this intrinsic carrier concentration is depending or is the strong function of the temperature. Now let's relate it. It is related by the formula given by this equation, and it is very important. In this equation, you can see that the intrinsic carrier concentration is directly depending on the temperature, where the B is the material dependent parameter and this K is the Boltzmann constant, and Eg is the energy gap, where electron volt value is 1.6 10 to the power minus 19 joule, and T is the temperature in Kelvin. So you can find out the intrinsic carrier concentration at any temperature. So let's recall all the important facts of the topic. The semiconductor is the material whose conductivity lies between the conductor and the insulator. Among all the semiconductors, silicons are the most commonly used semiconductor in IC technology because it is abundant in nature and its thermal energy is favorable for the IC devices. And the intrinsic semiconductor is nothing but the pure crystal, where intrinsic semiconductor behaves as insulator at 0 Kelvin, while at the room temperature the thermal energy is sufficient to create the free electrons, and thus it can conduct the electric current in effect of the electric field. When there are free electrons, then there will be holes, and holes have the equal magnitude of the charge of the electron but in opposite polarity. At thermal equilibrium, the concentration of free electrons and holes are equal, and it is given by the intrinsic carrier concentration. These free electrons and holes can also recombine, and this process is called recombination process, whose rate is ultimately depending on the temperature, which is given by the formula this, and the standard value of this intrinsic carrier concentration is 1.45 10 to the power 10 per centimeter cube at 300 Kelvin. So let's see the frequently asked questions from the topic. The first one is, which semiconductor material is commonly used in IC technology and why? I hope students you have watched the video thoroughly and you will be able to answer this. The second one, how the intrinsic carrier concentration affects the recombination rate with increase in temperature. It is directly depending on the temperature. And the last one, calculate the intrinsic carrier density for silicon at 50 Kelvin. Okay, I hope you can calculate it. So students, problem on the intrinsic semiconductor are not limited up to these three. I will present a video where you will find the questions asked in the competitive exams like ES, PSU, GATE and the technical interviews. So please follow the channel and I hope you like the video. So please subscribe it and share the video, and if you have any queries regarding the analog electronic circuit, or digital circuit, microprocessor and microcontroller, you can write me in the comment section or mail me. My mail ID is given in the description of the video. Thank you so much and have a nice day.